Often, people will be comfortable with the conceptual idea of a function, that it is a correspondence between a set of inputs and a set of outputs, in which each input is paired with exactly one output. When it comes to using functions in the world of mathematics, the complication is that these diagrams we've been using, where we have sets and arrows connecting inputs and outputs, or we have sets of ordered pairs, or we have a long list of if-then statements, is that they're not efficient. It takes a lot of effort to convey a little bit of information. Mathematically, we want to convey a lot of information with little effort or little notation. When we have a situation where we do have a function, and the given y values are a function of the given x values, we say y is a function of x. When we say this, y is a function of x, we're saying that the y value will depend on the original choice of the x value. But mathematically, we convert this statement, y is a function of x, into symbolics. And the symbolic way of writing this is y equals f of x. Y equals f of x is just an abbreviation for y is a function of x. When we write the statement y equals f of x, x is the independent variable or the input variable. Y is called the dependent variable or the output variable, and f is simply the name of the function. We tend to choose to use f as the name of the function because the word function starts with the letter f. But if you're using more than one function in a given situation, the name of the function can change, and it is completely arbitrary. We might have one function named f, another one might be called g, and another one might be called h. Other than identifying essentially which vending machine you will be using, the name of the function does not play a role in how the function operates. What is important to recognize in this function notation is that the x value is always inside the parentheses, the y value is always on the other side of the equal sign, and most importantly, these parentheses around the x do not represent multiplication. They are simply a way to separate the input value from the name of the function. So let's practice this with a particular example. We are first asked to verify that the set of ordered pairs A1, Coke, B1, Pepsi, C1, RC Cola, and D1, Jones Cola is a function. Well, since each x value is paired with exactly one y value, this does check out to be a function, and we will let y equal f of x be defined by that set above. So when we go to use this function notation, and we are asked to find f of d1, we need to recognize that what is being given inside the parentheses is always an x value. And so being asked to find f of d1 is really the question, what y value is the x value d1 paired with? Well, if we look through the list and we find d1 as an x value, we can see that d1 is paired with Jones Cola. So f of d1 will equal Jones Cola. It equals Jones Cola because Jones Cola is the y value paired with the x value of d1. In part B, we are asked to find f of c1. Again, it is important to recognize because the c1 is inside the parentheses, c1 is an x value. And so I'm essentially being asked, what y value is paired with the x value of c1? If I go back to my set of ordered pairs, I can see that c1 as an x value is paired with the y value of RC Cola. So f of c1 equals RC Cola. Again, f of c1 equals RC Cola because RC Cola is the y value that is paired with the x value of c1. In part C, we are asked to solve the equation f of x equals Pepsi. There are three things that should stand out in this statement. The first is that we're being asked to solve, and what we're being asked to solve is an equation. We need to solve the equation f of x equals Pepsi. The second thing that should stand out is that we are trying to solve this equation for x. We do not know the x value. That is what we're trying to find. And the third thing that should stand out is that since it equals Pepsi, Pepsi must be a y value. So this equation is essentially asking, what is the x value paired with the y value of Pepsi? Looking back at our table, we can see that B1 is paired with Pepsi. So in trying to solve this equation, f of x equals Pepsi, and knowing that B1 is paired with Pepsi, we can solve this by finding that the x value must be B1. Given that I am solving an equation, though, it is standard to write this as a solution set. And finally, in part D, we want to solve f of x equals coke. Again, we are solving an equation, so it's important to recognize that we are trying to find an x value. We don't know the x value, that's the question. So if we don't know the x value, then the coke value given must be a y value. And so the question we are trying to answer, what is the x value paired with the y value of coke? When we look through the set of ordered pairs, I can see that A1 is paired with coke. So the x value we're looking for is A1. But since I was asked to solve an equation, I again will finish off with that solution set notation. So the solution set is the set A1. Again, most people find the conceptual idea of a function to be comfortable. Each input is paired with exactly one output. Each x value is paired with exactly one y value. What people tend to find uncomfortable about functions initially is the function notation. Recognizing whether what is given is an x value or a y value, and in turn, are you looking for the y value or the x value? If the value is given in the parentheses next to the function name, it is an x value. On the other hand, if the value you're given is on the other side of the equal sign from the function notation, then the value you are given has to be a y value. It is crucial you know, are you starting with the x or the y before you try to answer the question.